What we're working on in this video is how to solve absolute value equations that include equality and inequality. So there are going to be problems that look like this, this, and this. Now let's work our way up to that. Now, originally, the problems that we typically solve before this class that have absolute value is something like this or this. What this is asking for is how far is -2 to the center. In this case, it's 0 on the number line. So if you were to say, how far is this distance? Well, it's 2. The reason why it's positive is because we're talking about a distance. No one ever mentions that they live -2 miles from someplace. It's always a +2. So whenever we talk about distance, we always use a positive number. That's why the absolute value of -2 is 2. Now, if we were to say how far is 2 from the center, that would also be 2. So some people have been taught that what absolute value means is just remove the sign of the number. In these sort of simple problems, that's absolutely true. So let's use a little logic and intuition to see if we can understand how to resolve these absolute value equations. Now, if we were to ask ourselves, what numbers could I put into this equation and get a true statement? So for example, if I put -2 or 2 in here, I would get a true statement because the absolute value of -2 is 2 and 2 is equal to 2, and the same here. But if I were to put any other number, some number bigger than 2 or in between -2 and 2, so let's say something like -1 or 3, we would get a false statement because the absolute value of -1 is 1, and we could see that this is not true, and we could see that this is not true. So the only two numbers from this number line that I could put into this equation and get a true statement is basically -2 and 2. Now, let's say we were to play this game with the less than equation. So let's put a number like, let's say -3. -3 is equal to +3, and +3 is not smaller than 2. So this would not be true. But if we put the points that are in between -2 and 2, we can see that if we put -1, if we put 0, if we put 1, all of these would turn into true statements because the absolute value of -1 is 1, and 1 is less than 2, 0 is less than 2, and 1 is less than 2. And we could see that even if we used fractions, that let's say -1 and 1/2, or let's say 0.7, these would all be true statements also. So we'll make sure this looks like an equal, and we'll show you that everything that's in between is satisfies the less than equation. Now let's do the same thing over here. Now let me sort of highlight this so we can see it better. So what I'm trying to show is that what the equal does is give you the endpoints, and what the less than does is give you the interval that's in between the two numbers. Now, it seems to reason, if we just look at this, that this will give us the outer portions. So let's try it. Let's put a 3 in there, or let's put a -3, and we could see that this gives me a true statement, right? The absolute value of 3 is 3, and 3 is greater than 2. The absolute value of -3 is 3, and that's greater than 2. And we can see that that's also true for decimals that are bigger than 2. So for example, if we did 2.1, or we did a fraction, -2 and 1/2, that all of these would fulfill this greater than statement. So everything that is bigger than 2 or smaller than negative 2 satisfies the greater than statement. And then let me do it by the highlight that portion. Okay. Now, we could see that another way of saying x is equal to 2 is to say that x is equal to either negative 2 or 2. These are the only two values that satisfy this equation. Okay, so this can turn into that, right? Over here, we see that x less than 2 will give me the middle interval between negative 2 and positive 2. So we can rewrite this like that. And we could see that greater than gives me everything that's outside of the negative 2 and 2. So we can rewrite this as x less than negative 2 or x greater than 2, right? X less than negative 2, x greater than 2. And since these two intervals are not connected, we put an or in between them. Okay. Now, if we were to change all these values of 2's and just turn them into a constant, we could get a general formula for removing absolute values. So if you have an absolute value and an equal sign, it turns into this. If you have an absolute value and a less than sign, it turns into this. And if you have an absolute value and a greater than sign, it turns into this. So this relationship allows us to get rid of the absolute value and use all the algebra that we knew before. So whenever we are trying to solve one of these absolute value equations, they all start out the same, regardless of whether you have an equal, a less than, or a greater than problem. So the first thing we want to do is we want to isolate the absolute value. I want this problem to look like the absolute value is equal to something. So when we do pattern matching, we can see that we just want to get rid of that 7. Okay, so I'm going to add 7 to both sides. And we'll see that we get 2x plus 3 is equal to 13. Now, the next thing you want to do is you want to make sure that this constant is positive. If it's negative, we have to do something else. And we'll do that. We'll show you what happens if this is negative further down in the video. But for right now, it's positive, so we keep going down our rules. Since this is positive, what we do then is we pick our equal, less than, or greater than rule. What we want to do is we look at this right here. And we say, do we have an equal, a less than, or a greater than? In this case, we have an equal. So this is the rule that we're going to use. Now, if we do pattern matching, we can see that if I want to get rid of the absolute value, then I have to add a plus and minus to the side opposite of the absolute value. So what we're going to do is we're going to get rid of this absolute value. And then on this side, we're going to add a plus and minus. Okay. Now, what this means is that we have two equations here. We have 2x plus 3 is equal to minus 13. And we have 2x plus 3 is equal to positive 13. Okay, and all we do now is we isolate the x. So let's solve for x. We're going to subtract 3 from both sides. And then we're going to divide both sides by 2. Again, we're going to do the same thing. We're going to get rid of that minus, that 3 by subtracting 3 on both sides. And then we'll get 2x is equal to 10. And then we will divide both sides by 2, and we'll get x is equal to 5. So these are two possible answers. So once in a while, when you use absolute value, when you're doing an absolute value problem, you may get what's called an extraneous solution, a solution that is not true. So the way to look at it is that if there's an answer, this is what it is. So we have to double check to make sure that these are not extraneous, to make sure that these answers actually work. So what we're going to do is we're going to plug in -8 back into this original equation. So this is where we double check. Just plug the -8 back into the original equation. So I just plug this into here. And we'll get -16 plus 3 minus 7 is equal to 6. We'll get -13 is minus 7 is equal to 6. 13 minus 7 is equal to 6. 6 is equal to 6. Okay, now let's do the same side over here. When I plug this into here, I'll get 2 times 5 plus 3, 10 plus 3, absolute value of 13 minus 7 is equal to 6, and then 13 minus 7 is equal to 6. 6 is equal to 6. So we can see that both of these end up in a true statement, so both of these answers are correct. So that's a correct answer, and this is a correct answer. Now, truth be told, if you have one of these problems where you have just a single number on the right side, and you check for and you do the check for whether the constant is negative, it should always work. But we'll show you later in the video an example of something that doesn't work. So let's try working on these problems and see the difference between equal, less than, and greater than problems. So the first thing we want to do is we want to isolate the absolute value. And we do that the same for each one of these three problems. So let's do that. Let's isolate the x minus 1. So I'm going to add 3 to both sides. And then I'm going to divide both sides by 2. Then I need to double check that this is positive, and that constant is positive, so I should keep going. Now, we have an equal sign here. So we're going to use the equal pattern. Okay, now, what we want to do is we want to get rid of the absolute value. So in order to get rid of the absolute value, I'm going to add a plus or minus to the right side. So let's get rid of the absolute value. Add this plus or minus over here. So that means now that I have two equations. I get x minus 1 is equal to -4, and I get x minus 1 is equal to +4. So if I add 1 to both sides, I get x is equal to -3. And over here, if I add 1 to both sides, I get x is equal to 5. And then what we have to do is we have to double check. So let's double check. Let's plug this back into here. So I get 2, and then the absolute value of -4. Now, this is where students get in trouble. Just simplify the inside of the absolute value. The absolute value does not apply until you have a single number. You cannot distribute. Anything from the outside of the absolute value cannot impact anything on the inside of the absolute value. So you can't distribute the 2, you can't subtract the 3. The only thing you can do is simplify the inside of the absolute value, turn it into a single number. Now, between this 2 and this absolute value is a multiplication, right? So we have a multiplication here, and we have a subtraction there. When we get rid of the absolute value, you should have the same operators. You should have a multiplication there and a subtraction there. So this absolute value makes the number inside here positive, right? So these are just parentheses. And then we do the whole PEMDAS thing. We get 8 minus 3 is equal to 5. 5 is equal to 5. And that's better. Okay. So we have a true statement, so that's a good answer. We do the same thing for x equals 5. We're going to plug this into the original equation, and we'll get 2 times 4, 8. 5 is equal to 5, and that's also a true statement. So both of these are good answers. Okay. Now, let's do this problem. This problem is a less than problem, so we're going to use the less than rule. But first we started out in the same way. What we want to do is we want to isolate the absolute value. So let's make the x minus 1 all by itself. We do the same thing. We add 3. And then we divide both sides by 2. Okay. Now, let's look at this pattern. You can see that this part looks the same as that part with just no absolute value. So let's do that. We have x minus 1 is less than 4. We just remove the absolute value. Now, the additional part is this over here. We have to add the negative of that constant on the right side and the less than. So we're going to put a negative and a less than 4 on this side. Now, to solve this, anything you do to, you solve this the same way that you would solve this. In order to isolate the x, I would add 1. But since we have 3 sides, you're going to add 1 there also. Okay. Now notice that we got the same numbers, right? That's how it works if you start out with the same expressions, even though the inequality is different from the equality. Now, the thing here is we don't double check this one. What we do is we check to make sure that this number is smaller than that number. We're saying x is in between -3 and 5. That's what we're saying here. As long as this number is smaller than that number, you have a correct answer. Right? We'll write in interval notation. If this number was bigger, then we would say undefined because it wouldn't make sense. You have to go small number, big number on the real number line. Okay, now let's do the greater than rule. So over here, we have a greater than or equal. So we'll use the greater than rule. Just know that whether it's greater than or equal or less than or equal, you still use the same rules up here. Okay. Now, let's do the same thing that we've done before. Let's isolate the absolute value. Oops. No, +3. My bad. And then I'm going to divide both sides by 2. So now I get x minus 1 is equal to 4. Oh, sorry. These should all be greater than or equals. My bad. Okay, now we're going to use the greater than rule. Okay, so when I look at this right here, this looks like this just without the absolute value. Oops. And then we should have an or. And then when we compare this side over here, this has a less than and a negative, right? So we get rid of the absolute value, but we have to add the less than and a negative. So now we have x minus 1, a less than, a negative, and then the 4. Okay, so if I add 1 to both sides, I should get x is less than minus 3. And over here, I should get, or x is greater than 5. So what's happening here is that we're saying that x is smaller, x not equal, sorry. X is less than or equal to negative 3, or x is greater than 5. Now you have to make sure that you put the negative on first, because this is supposed to be the first interval and then the second interval. Whenever we convert this to interval notation, we always go from smaller on the real number line to bigger. Now, if we sort of think of this in terms of interval notation, we'll have negative infinity to negative 3, and then because that's an equal, we will put a bracket there. And then instead of an or, we put a union. They mean the same thing. It means that I have two intervals that are not connected. And this U is a union sign that sort of connects these two non-connecting intervals into one answer. Now, let's try these problems. We talked about having to check whether the right side is negative or not. Let's actually show you what happens when the right side is negative. So the first thing we want to do is we want to isolate the absolute values. So I'm going to subtract 11 from both sides. And I get so we see that over here, this is a negative number. In the previous problems, whenever after we isolated, we had a positive number, so we can use one of the equal, less than, or greater than rules. See, and every time we isolated, we had a positive number here, here, and here. That's why we kept moving on. Over here, we have a negative number, so we have to stop and we have to use logic. Now, when I look at this absolute value over here, the absolute value of any number will either be 0 or a positive number. It's impossible for me to get a negative number because I have an absolute value over here. So let's just use logic. Can 0 or a positive number ever equal to a negative number? And the answer is no, right? They can't be the same number. So the answer to this is undefined. Now let's do the same thing here. I'm going to subtract 11. Okay. Again, we have to stop because after we isolated, we have a negative number. So the absolute value of this, I don't know what the answer is going to be, but I do know that this has to be 0 or a positive number. So is 0 or a positive number, can that ever be smaller than negative 6? No. 0 and positive numbers are always bigger than a negative number. So this is also undefined. Okay, so let's do this last one, greater than. Let's subtract 11 from both sides. And we end up getting x minus 1 is greater than minus 6. Now, this right here is a negative number. And we want to know over here, since this is an absolute value, this is a 0 or a positive number. Okay, so we want to know can a positive number be greater than a negative number? And the answer is yes. 0 or a positive number is always going to be bigger than a negative number. So in this case, any number I put in here will fulfill this equation. We'll make a true statement. Pick any number you want. Let's say 17. Just for kicks. Let's just put 17 in there. See, you can see that any number that we put in here will give us something positive, at worst 0, and that'll always be bigger than a negative number. So since any number works, our answer is negative infinity to infinity. Now, early in the video, I kept having you double check any problem that has a equal sign in it. Now, every time it's worked, so I'm going to give you an example of one that doesn't. Now, this is a little different because I have an absolute value on both sides, but it works just the same. And just know that in this case, this will always work if you have an absolute value on both sides. This is where it won't work, okay? When you have absolute value on this side and a variable on the right side. So first, let's do the one that always works. Okay, now, we're going to follow the same pattern here. We're going to get rid of the absolute value. And we can get rid of the absolute value here as long as we put a plus or a minus. Now, the next question someone usually asks me in class is, does the plus or minus have to be on the right side? And the answer is no. As long as you have the parentheses over here, you could put the plus and minus over here also. Don't put plus and minus on both sides because you'll waste some time. You only need plus or minus on one side. Now, it's important that you have the parentheses here because this negative is going to distribute to the 4x and to the minus 9. So this will turn again into two equations. And then this part over here will turn into. Okay, so it's really important for you to see that this minus over here, it's going to distribute. You're going to multiply -1 times that and -1 times that. So now you'll get 2x plus 3 is equal to -4x plus 9. And if I add the 4x on to both sides, and subtract the 3, I'll get 6x is equal to 6, or x is equal to 1. Okay, now let's do the same thing on this side. Okay, we're going to subtract the 4x to both sides. And then we're also going to subtract the 3 to both sides. And now I'll get -2x is equal to -12. And then when I divide both sides by -2, I should get x is equal to 6. Okay, now let's double check both of these. All right, so let's double check. I'm going to plug in x equal 1 into here, and I'll get 2 times 1 plus 3 is equal to 4 times 1 minus 9. So over here I'll get 5 is equal to -5. And when we take the absolute values, we'll get positive numbers. And then boom, we're done. That's a good answer, because when I double check, I get a true statement. Now let's do the same thing over here. Let's plug 6 into here and here. So we get 2 times 6 plus 3 is equal to 4 times 6 minus 9. So now we have 12 plus 3 is equal to 24 minus 9. So we get 15 is equal to 15. When I take the absolute value of both of those, I get 15 is equal to 15. I get another true statement. So this is a good answer. Now, let's see how this problem is different from this problem. So we're going to do the same thing. We're going to get rid of the absolute value by putting a plus or minus on this right side. And then this will turn into the same two equations. You'll get 2x plus 3 is equal to minus 4x minus 9. And you'll get 2x plus 3 is equal to 4x minus 9. And then we'll distribute that minus. 2x plus 3 is equal to minus 4x plus 9. And then we're going to add 4x to both sides and subtract 3 to both sides. And we'll get 6x is equal to 6. And we'll get x is equal to 1. So see that this computation is exactly the same as what we did over here. Same thing over here. This is the same thing as that. So when we subtract 4x to both sides and subtract negative 3 to both sides, we'll get negative 2x is equal to 12 and x is equal to 6. So notice that this part right here and this part right here are exactly the same. Okay, now let's look at where they're different. When I plug this into here, I'll get 2 times 1 plus 3 is equal to 4 times 1 minus 9. 5 is equal to minus 5, right? 4 minus 9 is minus 5. When I take the absolute value of this, I get 5 is equal to negative 5. That is not true. So do you see over here, because we had the absolute value, it made that positive. On this problem, we don't have an absolute value, so we get a false statement. So this is a extraneous answer. It's not a solution. X equals 6 is going to be our only solution. So let's plug in 6 into here. So we get 12 plus 3 is 15. 24 minus 9 is 15. And the absolute value of 15 is equal to 15. That's a true statement, so this is the correct answer. Now, if you found this video helpful, please like and subscribe so other people can find it. Thank you.